Trigonometric identities and equations. This is chapter 10 from the Pearson textbook. This is the learning for exercise 10b. You'll no doubt know by now that for some angles it's worth knowing what the exact sign of that angle is, rather than having your answer as a decimal that you have to round off. It's worth knowing some angles exactly, either as an exact fraction or as a surd. And these two triangles here help you understand where the signs of these angles come from. Although there's all sorts of videos on YouTube with ways to remember them, but it's important that you understand where they came from. Okay, this first diagram, imagine it's an equilateral triangle, so you may have to use your imagination. I'm sure my bottom side is longer than those two. Never mind. That's supposed to be an equilateral triangle, and each side is 2. It means, of course, that each angle is 60 degrees. I'm going to label these two for now. I shall leave the top one. So there's my equilateral triangle. I'm going to drop a vertical from here. So it cuts my triangle in half. That's a right angle there. So that's one. And that's one. This angle here is now 30 degrees. And using a simple bit of Pythagoras, I'm going to work out this side here. I'm sure you can see it's the square root of 2 squared minus 1 squared, which is the square root of 3. So there's my triangle. I can now use this triangle to give me exact values for sine, cos, and tan of 60 and 30 degrees. So let's deal with the 30 degrees first. The sine of 30, sine is opposite over hypotenuse 1 over 2. That's a nice easy one. Sine 30 is 1 over 2. Cos of 30 is adjacent over hypotenuse root 3 over 2. And tan of 30, tan is opposite over adjacent 1 over root 3. I can do the same thing for 60 degrees. Let's do sine of 60. Sine is opposite over hypotenuse root 3 over 2. Cos of 60 is 1 over 2. Tan of 60 is opposite over adjacent root 3 over 1, which is just root 3. I'm sure you've spotted by now that sine 30 and cos 60 are the same, that cos 30 and sine 60 are the same, and that tan 30 and tan 60 are just the reciprocals of each other. So when you're asked to find the exact value for the sine, cos and tan of something, almost certainly you're going to be dealing with one of these or a multiple of one of these. Okay, let's come over to this triangle here. This is an isosceles triangle where these two sides are 1. That's 90 degrees. So these two are 45 degrees. A little bit of Pythagoras will tell you that this is the square root of that squared plus that squared. 1 squared plus 1 squared is 2, the square root of 2. And I can use this to write down the sine of 45, the cos of 45, and the tan of 45. Sine of 45 is opposite over hypotenuse, which is 1 over root 2. Come back to these two in a minute. Cos of 45 is adjacent over hypotenuse 1 over root 2. And tan of 45, 1 over 1, is just 1. Now I have left these two and this one over here with a surd on the denominator. Now you'll remember from year 11 your lessons on rationalizing the denominator. You will often see this one written as root 2 over 2, root 2 over 2, and this one you'll often see written as root 3 over 3. But those are your exact values for the sine, cos and tan of these three angles. Whenever you see a question where the angle is 30 degrees, 45 degrees or 60 degrees, watch out. They probably want an answer that's in one of these forms. Bearing that in mind and knowing what we knew from the previous lesson, we know that actually 30 isn't the only angle for which sine of 30 would give me a half. What other angles will give me a half when I find the sine of that angle? Well, let's do our ACTS or cast diagram. Let's do 30 degrees. It's about here. It's positive. I'm dealing with the positive ratio here. So sine is positive here. It's positive over here. So I'm going to draw another angle there where that is 30 degrees. So not only does this angle give me a half, but also this angle. And this angle would be 180 less 30, 150. So with a bit of luck, sine 150 would also give me a half. I can check it on my calculator. Sine of 150 is 0.5. So it's more than this, just these angles I can find the sine, cos and tan for and give an exact answer. Any angle that's at this position of 30 or minus 30 or at 45 or minus 45 or 60. Any of these angles, 30, 45, 60, this angle, this angle, this angle, all these angles going forwards and backwards, you can find the exact value of sine, cos and tan for each of these angles.